because we are discussing the thyristor gate characteristics. Gate to cathode. Gate to cathode. What is that? It is just a kind of diode. So that means VG, IG. If there will be a two-layer PN and we are considering the highly doped to lightly doped, doped. So there will be a range of doping from highly to lightly. So that's why likewise our characteristics is somewhat like this. If it is a highly doped, then current is more changing than voltage. So very little voltage can give the large current. Let it be a curve 1. If you are taking towards the lightly doped regions means larger voltage, large voltage change, and current is lesser, curve 2. So this is your lightly doped. This is your highly doped. If this axis can be taken as a G and this one can be taken as a VG, then this is your curve 1, this is your curve 2, and this is your average power curve. P average. So all the operating point, how the operating point can be taken, we have to draw the load line. It is your lightly doped characteristic, it is for the highly doped characteristics, H, L. That means all other pattern, it should be lies between these two. That means this can be operating point, this can be operating point, this can be operating point. This can be operating point. So all other operating point must be lies between these 2 points. So anode, this is your cathode, this is your gate. Gate circuit will like this. E VG, IG, RG. Let it be R or RS, source resistance, source voltage. So what is the KVL equation now? KVL equation is equal to, if you are going to write the KVL equation for this, ES is equal to RS IG plus VG. Plus there will be a VGK, forward voltage drop. Forward voltage drop in gate to cathode junction. Gate to cathode junction. This can be taken as a 0. I'm taking this can be very minute drop is there, maybe 0.7, maybe 0.3, maybe 1 volt, so that can be neglected. So that means only you have a ES is equal to RS IG plus VG. This is your equation. You can easily find out the load line characteristics. If we are trying to find out the load line means what? Set of operating points like this. This is your VG. Let it be IG in x-axis. This is your VG. So how we find this point? By putting VG is equal to 0. We are going to put VG is equal to 0. Then IG is equal to ES upon RS. So this is your ES upon RS. For this point, putting in this axis, what you find, only VG is there and IG is 0. So putting IG is equal to 0. When IG is equal to 0, what you will find? ES is equal to VG. So this is your ES. So this is your load line. And in order to find out the gate characteristics, your operating point, this cross section must be taken into account, VG into IG. There is two kinds of triggering in thyristors. First is continuous time triggering, or it is also known as continuous pulse triggering. Continuous pulse triggering, that means a continuous DC voltage is going to be connected. If this is your complete cycle, let it be T1. Let it be T1. If this is complete cycle, so all this complete cycle you will find the DC voltage is connected, or maybe control signal is connected in the gate terminal of, this is your T time, this is your amplitude. Continuous pulse triggering means a continuous signal is connected in the gate circuit. What is the application of this kind of pulse triggering? Continuous pulse triggering. When the SCR is going to be fed a highly inductive load, this kind of continuous pulse triggering is used for that particular application, such as fed a highly inductive load L. Let there will be a small kind of resistance is also there, but highly inductive in nature. So this is a supply voltage, source voltage, ES, yeah, VS. So this kind of circuitry, you will need a continuous pulse triggering, CPT, continuous pulse triggering. Why? If you are going to write the equation, so Vs is equal to L di by dt. Am I correct?
Yes, sir.
If you are neglecting the small resistance, what you will find? Es is equal to L di by dt. we can write it as, for a small duration of time, let Vs is equal to I by T. If you are taking a very small duration, very delta duration, so that means T can be written as, time can be written as inductance into current through inductor divided by what? Supply voltage. This is time. That is a minimum duration pulse needed. This is the time duration of pulse needed to turn on this thyristor. Gate pulse duration. This is what? This is the gate's pulse duration. If it L is too much higher, if L is higher, that means you are requiring the some kind of wider pulse to supply the gate. So that means if you are increasing the L, your T is also going to increases. So L, if a highly inductive load, that means your continuous firing is applicable in this kind of circuitry. In order to supply the highly inductive load, you will need a continuous pulse triggering method. Why? I explained you. Because T is equal to L I upon Vs. L, that means T, what is T? Duration of gate pulse. T is proportional to the L. If L is lower, your T is lower. If L is higher, your T is also going to be higher. Okay? Pulse triggering method. Previously was, what is that? Continuous pulse. Now it is pulse triggering method. In pulse triggering method, what you need for a cycle, for a T1 cycle, you are going to apply this much of duration. This is your T. Again, soon after this cycle, you will again have to be a pulse T. That means for every cycle, you need to have a pulse to turn on this SCR. This is your complete cycle. Up till now, this is your T1 is your complete cycle. And for a particular cycle, only T is the duration. This is your on duration. So this type of pulse is going to apply a thyristor to turn on pulse triggering method. What you find here in the continuous firing, PG max is equal to PG average, because there will be a continuous firing. So throughout the cycle, you will have a continuous signal. In that case, Vg into Ig is your P max, which is also equal to PG average. This is applicable to the continuous pulse triggering. But for the case of this pulse triggering, this PG average is less than PG max. Which is PG max, and this PG average is not equal to, rather PG average is less than the PG max. And mind it, PG average is not equal to Vg into Ig. It is Totally wrong. It is not equal to Vg into Ig, but Pg max is equal to Vg into Ig during on period. During on period, Pg is equal to Vg into Ig. And how we are going to calculate the Pg in this case, P average? P average is going to be calculated as Pg max. Pg max कितने देर के लिए? How much duration it is? It is for T on duration and total time period divided by T1. This is your Pg average. What is this? T on upon T1. Actually, T on upon T1 is your duty cycle delta. T on upon T1 is equal to delta. It is your duty cycle. Duty cycle. What is duty cycle? For a complete cycle, how much duration is on period? This is your duty cycle. It is a ratio of T1 upon total time. In ordinary sense, in the physical parameters, I'm going to tell you, if 24 hours is a total time period in a day and you are working for only 8 hours, then definitely your duty cycle will be 8 divided by 24. 8 divided by 24, it is your duty cycle. If you're working for 10 hours, then 10 divided by 24 is your duty cycle of another boy which is working for 10 hours. Are you getting it?
Yes, sir.
So in that case, in pulse triggering, the two relations are there. First is your P average is never going to be equal to Pg max. Rather, I should say Pg average is less than the Pg max. Getting it? Next, in extreme cases, Pg average is equal to duty cycle times Pg max. Our duty cycle can be also written as T on upon T1 Pg max. It also can be written as Pg average is equal to T on F Pg max. What is F? This is your triggering frequency. This is your triggering frequency. You can see here, if triggering frequency is directly proportional to Pg average. If triggering frequency is larger, your Pg average is also going to be larger. Okay, getting it? Yes or no?
Yes, sir. Yes, sir.
There is another factor is also there. We are writing as Pg average is equal to T on triggering frequency into Pg max. Okay, this is your relation. Now, if I'm going to take this as a constant, it is also a constant given in the manufacturing side. Manufacturer is given your P max defined. It should be never going to be increases beyond the limit. Mind it, your Pg can never going to be exceeded. In order to reduce T on, reduce T on means SCR turn on. SCR turn on can be reduced, how? If F can be increased. Getting it? For
Yes, sir.
every constant power, if we are going to reduce this T on, we should increase that F. That means triggering frequency, if somehow if we increase the triggering frequency, your turn on time can be reduced. Okay?
Yes, sir. Yes, sir.
So for the high frequency application, this can be very much needed. Your turn on turn off time can be reduced for higher frequency application. Actually, we are going towards a high frequency application because filter designing is very much easier in that particular circuit for high frequency. So in order to deal with higher frequency application, we have to reduce the turn on this T on. In order to reduce T on for constant average power in the gate side, we have to increase the F. This is one side. Another side, we are using the pulse transformer. In the gate circuit, we are using the pulse transformer in order to connect this circuit. This is your power circuit. This is your power circuit. Anode to cathode circuit is your power circuit, and gate to cathode is your control circuit. Control circuit or triggering circuit. Power circuit is somewhat higher rating, but control and triggering circuit is somewhat the lower rating. That means lower rating. So in order to connect, I'm going to use a pulse transformer. Pulse transformer. The use of this transformer is that it provides the isolation from power circuit. Actually, PT is going to be used. PT means not potential transformer. It is a pulse transformer. PT here is your pulse transformer. Pulse transformer. It is a special kind of transformer which can be rated as V into time. That means volts microseconds. This is the rating of this pulse transformer. Instead of kVA, this transformer is rated as volts per microsecond. This is the rating of this transformer because the application of this transformer is to apply a pulse, a high frequency pulses. Okay, high frequency pulses is their objective, and here this pulse transformer is providing a. Here you can design a gate circuitry in the primary side. In the secondary side, it provides the isolation only. Somehow, if you increase the frequency, then size of this transformer is also going to be lower. This core size for high frequency application, the core can be a smaller size. So two advantages there for using the high frequency triggering pulses. First, turn on time can be reduced. Second is we can reduce the pulse size of the pulse transformer. Okay, getting it? It is example number 4.3. For an SCR, the gate cathode characteristics has a straight line slope of 130 full stop. For triggering source voltage of 15 volt and allowable gate power dissipation of 0.5 watt, compute the gate source resistance. Compute the gate source resistance. There is an SCR, and SCR gate cathode characteristics has a straight line and slope is having 130 degree. This is your slope. Slope is your 130 degree. Okay. This is your, this is your gate circuit actually. Neglecting the forward voltage drop in the gate to cathode circuit. So what is your equation now? E is equal to, if this is your Ig, if this is your Ig, then Rs into Ig plus Vg. Okay. If this is an equation of a straight line, if this is an equation of a straight line, we can represent it like this. Here is given your, this is gate to cathode characteristics. Gate to cathode characteristics mean two variables Vg and Ig. So this equation can be represented as Vg and Ig. So Vg is equal to E minus Rs into Ig, or Vg is equal to minus of Rs Ig plus E. Now this is your gate to cathode characteristics. Okay, gate to cathode characteristics. Now according to your question, slope, if we can compare it, y is equal to mx plus c, and according to your question, m is, or slope is 130 degree. If in your question there is given a straight line, means we have only going to take y is equal to this much of time, and you know slope is your 130. What is slope? It is a general calculation. M is equal to minus of r. Minus of r means slope is like this. Like this. This is negative slope. Because it is a straight line, so that means there is no E here. No E means only y is equal to some kind of y is equal to mx, Vg upon Ig. What that means? Rs. So here is, in according to the question, Vg upon Ig is equal to 130, and also given here allowable gate power dissipation. Gate power dissipation Vg into Ig is equal to 0.5 watts. So you are having the two equations. And solve it and find out the value of Ig and Vg. Okay.
Yes, sir.
You are having two equations, then you have to find out the value of Vg. And now, after finding Vg into Ig, you are going to put it here, here, and here. This, in this equation, you have to put it these values. After putting these values, and according to your question, So triggering source voltage is 15 volt. This is given as 15 volt. So now you can easily find out the source resistance. Okay. And according to your question, what is given? You have given the straight line slope 130 and you have given that 15 volt is source voltage, power dissipation 0.5 watts, and going to calculate the gate to source resistance, that means RS. So after solving this Vg into Ig 0.5 and Vg upon Ig 130, you are getting the value of Vg Ig. ये है ये समझ में आ रहा है? ये एक सर्किट है, मैं डिजाइन कर देता हूं उसको. Okay, this is your circuit. What happened? According to this question, we are going to find out this rating of this pulse transformer, rating of this pulse transformer, rating of this pulse transformer, and value of R. These two objectives are there. It is a gate question actually. You will find 2-3 years back this kind of question, it is there in the gate question paper. This is of 4 number, long question type. According to your questions, what is given here? The value of this resistance is your 1 ohm. Inductance value, this value is 150 millihenry. Supply voltage is 200. This is your 200. This positive, this negative. Ig max is given. It is given. These data are given in question. Ig max is equal to 150 milliampere. IL, load current. Load current is flowing here. IL is given as 250 milliampere. Actually, IL is your latching current, I think. This is your latching current. Latching current, and holding current is given as 150 milliampere. Minimum gate current, Ig minimum, is your 100 milliampere. And it is also given here the all the drops, whether it is a transistor or diode, it can be taken as a 1 volt. All the voltage drops, whether it is in transformer or transistor or diode, it is in 1 volt order. Gate to cathode junction drop is also 1 volt. Now tell me, what is the value of primary voltage here? Now I'm going to calculate. Let VP is your primary voltage here, and VPS is your secondary voltage. Okay.
Yes, sir.
Here is your 10 volt plus 10 volt. This branch is having the diode and resistance here, D and R. Assuming that base is having the on, because first chain, that means it is on. When the BJT is on, here is VSAT. V saturation means VCE. VCE, according to a question, can be taken as 1 volt, because transistor, diodes, gate to cathode junction during on state are 1 volt. When the BJT is conducting, VCE, that means collector to emitter voltage during on is 1 volt. Okay, so that means here is your 1 volt. Now tell me, voltage across this branch is what? Which is nothing but the VPP. What is that voltage? How much it is? Here is your 1 volt. Here is your 10 volt. Now tell me, what is the value of VPP? Are you getting it?
Yes, sir.
You
1 volt.
VAB. If this is your A, this is your B, you have to find the VAB.
9 volt.
VPP is equal to 10 minus
1.
10 minus 1 volt, that is
9 volt.
Because potential transformer is 1:1 ratio, it is only used for isolation purpose. So that means VPS is also 1/1 into 9, that means 9 volt. Okay.
Yes, sir.
VPS is your 9 volt. Up till here you will get 9 volt. Okay.
Okay.
Now this diode is having 1 volt drop. In this junction, because this is a DC signal, so diode is a reverse bias, so there is an open circuit. So no effect of this D2. Again, C is also having the open circuit because of this DC current. So there is no effect of C also, open circuit. So if this voltage drop across R is VR, and already you have given that gate to cathode drop is 1 volt. So now if you write the KVL equation here for secondary side, PS is equal to VD1 plus VR plus V gate to cathode. Okay, so VR is equal to now VPS minus VD1 minus VJK, gate to cathode. So that means VPS is your 9 voltage drop, in the diode D1 is your 1 volt, on state voltage drop across gate to cathode junction 1 volt is given. So at last you are having the 7 volt across the resistance R. Okay, you are getting the 7 volt.
Yes, sir.
In order to calculate the value of R, what is R? Is the ratio of voltage and current.
Yes,
And
sir.
in turn on the thyristor, you are supplying the maximum gate current. VR divided by IG max is equal to what now? R is equal to 7 divided by 0.15, 150 millihenry, which is equal to 47 ohms is the value of resistance.